Hi there, a warm Namibian welcome to all advanced subsidiary level mathematics learners and everybody else interested in learning maths. We are glad that you have joined us. I'm Brian Issa. In this educational video program, we're going to explain the remainder theorem and show you how to apply the remainder theorem to polynomials. Does this sound like Greek? Don't worry, we'll sort you out. Many learners struggle with the remainder theorem, but this lesson will walk you through exactly what you need to know so you can master it. We have just one learning outcome, and that is for you to be able to apply the remainder theorem to polynomials. But first, let's recap on what the remainder and polynomials are. Let's get to work. Well, as I said, we need to know what the remainder theorem and polynomials are in order for us to use them in maths. So, firstly, the remainder theorem. Do you remember doing division in arithmetic? Of course you do. For example, if you have 7 divided by 2, it is equal to 3 with a remainder of 1. Do you remember the correct vocabulary though? The dividend is divided by the divisor to get the quotient and the remainder. 7 is the dividend, the bigger number that is being divided. 2 is the divisor, what you are dividing by. 3 is the quotient, the answer. And 1 is the remainder. Okay, so what is a polynomial? Listen up. A polynomial is an expression which contains many terms, with at least one of them having a variable, such as x or y. Here are examples of polynomials: 5x cubed plus 2x squared minus x plus 4, x squared y minus 4xy plus 2y squared minus 1, 3m squared plus 5mn minus 2n squared. You also know from long division of regular numbers that the remainder, if there is 1, has to be smaller than whatever you are dividing by. In other words, the remainder must be smaller than the divisor. If you are dividing with polynomials and the divisor is a linear expression like x plus 4 or x minus 3, then the remainder will be a constant. That is, when you divide by x minus a, the remainder will just be some number. Now, the remainder theorem states that if a function of x is divided by ax plus k, the remainder is given by f of negative k over a. This sounds very complicated, but don't worry, we'll do an example. What is the remainder when 2x squared minus 5x minus 1 is divided by x minus 3? Again, 2x squared minus 5x minus 1 is divided by x minus 3. But we only want to know what the remainder is. The question does not require us to find the quotient first by long division or synthetic division. So we use the remainder theorem. The remainder theorem states that if f of x is divided by ax plus k, the remainder will be given as function of minus k over a, as you can see on the screen. Let's apply the remainder theorem to our example. When f of x is equals to 2x squared minus 5x minus 1 is divided by x minus 3. We don't need to do the division by x minus 3 by long division to find the remainder. We just calculate f of 3. K is given as minus 3 and a is given as 1. The remainder can be found from f of negative k over a, which becomes f of 3 over 1, which is f of 3. Let's do the calculation. In the function, replace every x with 3. This gives 18 minus 15 minus 1, which is equals to 2. The remainder will be 2. I hope you are still following. However, a much shorter way is to make the divisor equal to 0 and solve for x in the equation. If x minus 3 is equals to 0, it means that x is equals to 3. And then to find the remainder, calculate f of 3 in f of x is equals to 2x squared minus 5x minus 1. Now substitute 3 for x in the function, which makes it f of 3 is equals to 2 times 3 squared minus 5 times 3 minus 1. Evaluate and we get 18 minus 15 minus 1, which is equal to 2. Viola, it's not hard. Our remainder is 2, exactly as we had before, but by finding the answer by using a quicker method. Let's do another example. We have to find the remainder when f of x is equals to x cubed minus x squared plus x minus 1 is divided by 2x plus 1. Don't tell me you get spooked by this easy job. I told you all you do is to take the expression at the bottom of the line, meaning the divisor, and equate it to 0. The solution therefore is x is equals to negative half. 2x plus 1 is equals to 0. Now we should get x alone on one side, meaning subtract 1 on both sides. That's right. Now it is 2x is equals to negative 1, and then divide by 2 on both sides. This we get x is equals to negative half. This is how we get x equals to negative half. All that remains is to substitute a minus half into the expression. F of x is equals to x cubed minus x squared plus x minus 1, which gives us f of negative half is equals to negative half cubed minus negative half squared plus negative half minus 1 equals to negative 15 over 8. This means the remainder is negative 15 over 8. Please tell me you love this as much as I do. Well, eventually it has to be a little bit more difficult, but just focus on the method. It's still the same. Here we go with example 3. If 3x cubed minus ax squared plus bx plus 10 is divided by x minus 2, the remainder is 2. And when it is divided by x plus 1, the remainder is negative 1. This is given. Now the question is find the values of a and b. I hope you are not bowed over by so many letters in this problem. Just keep calm and stick to the method. This question is given the other way around from what we have seen before, where you were given the expression and were asked to find the remainder. Here you are given the remainders and asked for the expression. The fact that we are asked to find two variables a and b is a clue that we will use simultaneous equations. Here is what we know. When the divisor is x minus 2 is equals to 0, and therefore x is equals to 2. Now we substitute that value of x into the function to get an expression with a and b. F of x is equals to 3x cubed minus ax squared plus bx plus 10, meaning it is now f of 2 is equals to 3 times 2 cubed minus a times 2 squared plus b times 2 plus 10. We work it out and get f of 2 is equals to 24 minus 4a plus 2b plus 10. And finally, f of 2 is equals to 34 minus 4a plus 2b. But we know that the remainder is 2, so we can write an equation. 2 is equals to 34 minus 4a plus 2b. This simplifies to 4a minus 2b is equals to 32. and we have our first equation. Now do exactly the same with other remainder we were given. X plus 1 is equals to 0, therefore x is equals to -1. So when we substitute the value of x as -1, this becomes f of x is equals to 3x cubed minus ax squared plus bx plus 10, which is f of -1 is equals to 3 times -1 cubed minus a times -1 squared plus b times -1 plus 10. F of -1 is equals to -3 minus a minus b plus 10. F of -1 is equals to 7 minus a minus b. But we know that the remainder is -1, so we can write an equation -1 is equal to 7 minus a minus b. Simplify it to get a plus b is equals to 8 as our second equation. To find the values of a and b, solve the two equations simultaneously. We have 4a minus 2b is equals to 32 and a plus b is equals to 8. Divide equation 1 by 2 to get equation 3. Add equations 2 and 3 to get 3a is equals to 24, which gives a is equals to 8. Substitute 8 for a in 2, leading to b equals to 0. We have our answers. A is equals to 8 and b equals to 0. We have done it. Good job. We should check our answers in case we have made a mistake. Use a equals to 8 and b equals to 0. Find f of 2 to get the remainder. It is 2 as it should be. For the second remainder, find f of -1, and we do indeed get the remainder as -1. We are sure we are right. Knowing this will help you in your daily life in the future, especially if you plan to study something like engineering. Viewers, thank you for watching our lesson today. I hope it has made you feel more confident about applying the remainder theorem to polynomials. Before we say goodbye, let's have a summary of what we have learned today. Learners, we have seen in today's lesson that the remainder theorem states that if f of x is divided by ax plus k, then the remainder is given by f of -k over a. Now practice as many examples as you can. We still have 4 lessons on different topics in mathematics for AS level learners. I hope you still join me in lesson 2. Until then, bye-bye.